Welcome to the Laboratory Radiation Safety course. This course is one of a series on laboratory safety. In this course, you will learn how to work safely with radioactive materials. Consider the following scenario. Imagine that you are surveying a laboratory for radioactive contamination. The Geiger counter you are using registers acceptable levels of radiation, and your badge dosimeter is also within acceptable limits. Is this laboratory free of contamination? If you work with sealed or unsealed forms of radioactive material, you must receive training. This training consists of initial classroom or computer-based training, plus performance-based or on-the-job training. Continuing training must also be provided as new duties, hazards, or requirements arise. After completing this course, you will be able to discuss federally mandated training requirements for working with radioactive material. Identify types, characteristics, and example emitters of radiation typically encountered in the laboratory. Recognize the hazardous effects radioactive materials cause to tissue. Identify methods of measuring exposure to radiation. List safety procedures for controlling exposure to radioactive material. Recognize procedures for decontamination from radioactive contamination. And identify regulatory process and organizational procedures for use of radioactive material. We are exposed to an average of 40 trillion radioactive particles in a typical lifetime, around 15,000 a second. Click the slices of the pie chart for more information. The three major processes relating to radiation laboratory safety with which workers need to be familiar include radiation, ionization, and excitation. Radiation occurs through the process of radioactive decay. Radioactive decay occurs when an atom with an unstable nucleus decays until it becomes a stable atom, emitting radiation as it decays. As radioactive elements decay, they emit a variety of particles and/or electromagnetic energy. In this course, we will examine alpha and beta particles, gamma rays, and X-rays, all emitted by different radioactive substances. Click here to learn more about radioactive decay. Ionization occurs when an alpha or beta particle passes close enough to an atom's orbital electron to bump the electron completely out of its orbit. Move the charged particle close to the orbiting electrons to see an illustration of ionization. Excitation occurs when a charged particle transfers some of its energy to an electron orbiting an atom, exciting the atom to a higher energy state. This electron soon reverts to its normal energy state, and an X-ray is emitted. To see an illustration of excitation, move the charged particle to the orbiting electrons.